Okay, dear students, in this lecture I am trying to explain what's meant by Planck radiation formula. Last some lecture we were discussing about the energy distribution curve of the black body and Rayleigh-Jean's law and Wien's distribution law and Wien's displacement law and so on. So we have to got an idea that the Rayleigh-Jean's law and the Wien's displacement law are cannot explain this energy black body energy distribution curve perfectly. So that's why we need another theory for this energy distribution of the black body. So that's the Planck radiation law. So okay, so Planck radiation law, actually the energy distribution curve of the black body is something like this one. So we already familiar with this one. It means along x-axis lambda and y-axis energy density, and the for a higher temperature the energy density is more, and there is a peak for particular wavelength and so on. So these are the energy density curve, and our aim is to explain this a perfect theory for this. So the first one theory, the proposed is, as we discussed, Rayleigh-Jean's law. According to Rayleigh-Jean's law, the energy density for a range lambda and lambda plus d lambda is equal to 8 pi kt by lambda raised to 4 into d lambda. So according to this theory of the Rayleigh-Jeans, we try to draw this curve for this equation. So what we means, this theory is perfectly matched with black body energy distribution curve for a higher wavelength, but for lower wavelength there is a mismatch. This mismatch we already told, it's known as ultraviolet catastrophe. So for higher wavelength the Rayleigh-Jeans law is matched with the black body radiation curve, but it's not a good for lower wavelength. So this is not a good theory, there is some failure. And the same way, the second good theory for this one is Wien's distribution law or Wien's displacement law. So according to the Wien's, the energy emission of black body can explain using this equation: E lambda d lambda is equal to C1 into lambda raised to minus 5 exponential minus C2 by lambda t into d lambda, where C1 is a constant having the some value 8 pi kt, C2 is another constant is having the value lambda c. So this equation also trying to explain the energy distribution of black body, but this is perfect match with the lower wavelength, but it's not matched with, it's not good for a higher wavelength. So this also not a complete good theory for the energy distribution of black body. So we face some failure here, and this failure, why this failure is happening? So this failure seems that it's not a possible to explain it by a classical physics. So this is all are happening at the end of 19th century. So at the end of 19th century we have the some a lot of physics, from starting the Newtonian theory and some the Lagrangian, Hamiltonian and the electrodynamics we have. So such a whole theory what we have that time, it's in capability to unable to explain this theory, this black body radiation. So we need some new explanation or new theory for to explain this one. So that time the German theoretical physicist Max Planck came up with a new revolutionary idea. So Max Planck idea was the revolutionary one because it's a new at that time. So it's there is no connection with the previous theories. So this Planck idea, what I will explain what's Planck idea. Before that, Planck idea perfectly explain this black body energy distribution curve. And also this, more than that of a black body radiation curve, it's also a best starting to lead to a new framework or new formation of a physics. So that formation of new physics is also known as modern physics. From this development onwards, the physics is known as modern physics. Before this, Max Planck or this and idea is known as classical physics. So this the failure of Wien's distribution law or Rayleigh-Jean's law is due to the failure of classical physics to explain this phenomena. So this Planck idea is leads to the formation of a new physics known as modern physics, and also this is known as quantum physics. So now we come to the point, what's mean by Planck radiation law. So what's the Planck hypothesis? So Max Planck, according to the Max Planck, the atom in a uniform temperature enclosure. So if something object is in a considered as a temperature enclosure in which that substance we have a lot of atoms. So the atoms in a uniform temperature enclosures behave something like a harmonic oscillator. You know what is an harmonic oscillator? So any system which execute a simple harmonic motion, we can call it as an harmonic oscillator. So Planck considered as a atom in a temperature enclosure like a harmonic oscillator. So if when this harmonic oscillator vibrate, they can radiate energy. So it's a good idea. So when a oscillator can vibrate, it energy emission can happen. So this, the important thing is that this emitter radiation is not a continuous energy. So far at the end of 19th century till the 19th century, we know there is a all energy we consider is a continuous one. But from this point of onwards, the Planck put forward that in this case we consider this atoms are something like a harmonic oscillator and it's emitting the radiation. So but he considered that this emitted radiation is not a continuous energy emission, and instead of it is a discrete energy, it's a packet of energy. So its value is an integral multiple of a packet. So there is a minimum packet, and this energy distribution is always integral multiple of this minimum packet. So its value is an integral multiple of an atom of energy. It's atom of energy, and also known as a packet of energy is also known as quantum of energy. So one quantum of energy. So this one quantum having some value, and always this integral multiple of this one packet or one quantum. So this idea, that is a classical physics, we always deal with the continuous energy distribution, but here this is a new idea is called discrete energy idea. So energy value of a one quantum is known as EH nu, where nu is the frequency of vibration. So the energy is depend on the vibration of the frequency of this vibration, and H is a Planck constant. So he is equal to H nu is the one packet of energy, and always it can emit n H nu is the integral multiple of H nu. So n is can 0, 1, 2, 3 and so on that. So from this idea of Planck put forward a new formula to explain the black body energy distribution. So using this quantum theory, Planck reduced the formula. Thus formula is telling that energy density emitted for a particular wavelength lambda and lambda plus d lambda is having the value 8 pi hc into lambda raised to minus 5 by e power hc by lambda kt minus 1 into d lambda. This formula is known as Planck radiation formula. This is in terms of wavelength. If you want, if in terms of frequency, we know lambda is equal to c by nu. In terms of frequency, this equation can be written as E nu d nu is equal to 8 pi h nu cube by c cube into e power h nu by kt minus 1 into d nu. For nu is the frequency. So now we are going to check whether this equation, whether this theory can explain the Planck, this black body energy distribution curve. So we know for longer wavelength and higher wavelength there is a Rayleigh Jeans law and the Wien's displacement law are the. So okay, so for shorter wavelength, I consider the first case. I take this in terms this equation in terms of lambda. For shorter wavelength, this term which lambda kt in this denominator lambda kt, lambda t is very small for shorter wavelength, and e power h nu is actually this is hc by kt. Yeah? So I take e power hc by lambda kt is very large because lambda t is very small, so hc by kt become large, so e power hc by lambda is very large. So e value having some higher value, so I can neglect this minus 1 then. So one can neglect. So one neglect this equation can write e lambda d lambda. So only I took a larger, so this I neglected. So this equation become 8 pi hc lambda raised to minus 5 into e power minus hc by kt, only e power minus hc by kt. So I put this 8 pi hc, I put lambda c1 and hc I put c2. So I can write the equation C1 into lambda raised to minus 5 into e power minus C2 by kt. So this equation we already familiar. This is Wien's distribution law. So Planck radiation law for shorter wavelength, the equation is reduces to Wien's distribution law or Wien's law. So Wien's law is perfect match with the black body radiation curve for shorter wavelength. So it's okay. Now what about for longer wavelength? For longer wavelength, lambda t is very large. So e power hc by lambda kt, lambda t is very large. So hc by lambda t is very small. So e power something, e power x something is very small. For x is small, we can expand it. Binomial expansion is 1 plus x square by 2 factorial and so on. So I neglect the higher order term. I having only 1 plus hc by lambda kt. First order I took. So e power hc by lambda kt we can return as 1 plus hc by kt. Now I substitute this in the equation. E lambda d lambda is 8 by c by lambda raised to minus 5. 1 plus hc by kt minus 1. So 1 and 1 will cancel. Remaining hc by lambda kt is there. hc will cancel. Oh, lambda raised to minus 5 is there. It's having 1 lambda can cancel. Lambda raised to minus 4 will come. The remaining is t will come to the numerator. So 8 pi kt lambda raised to minus 4 d lambda. So this is nothing but it's a Rayleigh Jeans law. So it's proportional to or inversely proportional to fourth power of lambda. So for longer shorter wavelength, Planck radiation formula reduces to Wien's displacement law, Wien's distribution law, and her higher wavelength Planck radiation formula reduces to Rayleigh Jeans formula. So it means using the Planck radiation law, we can explain the energy distribution curve for the black body. We can explain both for longer wavelength, and it's also good theory for the energy distribution. So this formula is came up from the Planck hypothesis. So Planck hypothesis starting to a new physics known as quantum mechanics, and after this quantum mechanics we call the physics is known as modern physics. So this is a good starting of the quantum mechanics, and actually quantum mechanics is a new way of interpretation of the physics in new language, and language is known as quantum mechanics. So you may familiar with quantum mechanics more later. So this is all about the failure of classical physics and the success of Planck radiation law to explain the black body spectrum. So this is all about it. So hope you can read these notes and books, make a note on this one, make a clarity. Thank you.